we're going to solve equations by combining like terms today. And we've talked about like terms before when we talked about polynomials, so a little review for you here, some quick review. What are like terms? These are terms with the same variables, and those variables have the same exponents. So we'll give you some examples here. For example, if we had the term 5x squared y, then a like term would be like negative 6x squared y, or 1 over 5 x squared y, or just x squared y. As long as it has an x squared y, it's a like term. Unlike terms, well, obviously unlike terms aren't like terms. I didn't even write that down. I'll just give you some examples. So if we start again with our 5x squared y, some things that are not like terms are things like negative 6x squared. Okay, it's close, but no, there's no y, so that doesn't count. Or how about 1/5 x squared y squared? Nope, you got x squared and you got y to the first power, and here you have y squared, so that doesn't work either. How about x y squared? No, this x has a 2 and this x has a 1 and this y has a 1 and this y has a 2. Everything has to be the same, okay, in order to be like terms. And the important thing to remember from before is only like terms can be combined and like added or subtracted. Only the like terms can be added or subtracted. So for example, if we were adding together 2x squared y plus 3x squared y, they're like terms, so you can add them together. If you have 2 of this and 3 more of this, you now have 5 of this. It stays exactly the same, x squared y, right? So it has to be the same, and it stays the same. All right, so here's our steps now. I'm adding a couple. Step 1 is still something we did before. You're going to get rid of brackets by using the distributive property. The second step is new. Then you're going to combine terms on the same side of the equal sign. So that's super important. It's only on the same side of the equal sign. We'll take a look at that. Then you're going to do your isolating the variable. Remember, you're going to add, subtract before you multiply, divide. And the number 4 step, which I should have written before, but I'll just put it today, is check your answer by substituting into the original equation. Now that is optional, right? Sometimes it's more trouble than it's worth, but it is something you always can do, is to check your answer. So I won't do it every time, but I'll do it sometimes. Alright, so step 1, get rid of any brackets. So do we have the distributive property here anywhere? Yeah, we do. We have the distributive property right here. So let's do that first. We have 3 times m, which is 3m. And then I have 3 times negative 2, which is negative 6. Then I'm just going to rewrite the plus 5. And what the heck, for now I'll rewrite the 12 minus negative 5. Okay, step 2 is combine like terms on the same side of the equal sign. So basically, what you want to do here is just to look at one side at a time. So if I just look at this side of the equal sign, the left-hand side, do I have any like terms? I sure do. I have the negative 6 and the plus 5. So I'm going to combine those. This is just like when we simplified polynomials before. There's no like term with the 3m, so we keep the 3m. And then we can combine the negative 6 plus 5. What do you have more of, negatives or positives? You have more negatives, so it's going to be negative. And you have 6 negatives and 5 positives, which means you have 1 more negative. Okay, equals. And now we look on the other side of the equation. Is there anything you can combine there? Sure there is. You have 12 take away negative 5. Well, we don't want to take away negative. It's too hard. We would like to add, and the opposite of negative 5 is plus 5. Oh, 12 plus positive 5, that's no problem. It's 17. Great. Now we're down to a question like you did a couple days ago. You want to get this m by itself, so you have 2 numbers that are problems. So remember, you want to look for an adding or subtracting step first. Well, that would be the minus 1. You're going to do the opposite and add 1 to both sides. So that leaves you with 3m on this side. The 1's are gone. Equals 18 on this side. This is 3 times m, so you do the opposite. You divide by 3 on both sides. And if you do that, you end up with m equals 6. And there's your answer. Now, let's say that you did want to check this answer by substituting. How would you do that? Well, you'd write 6, which was our answer, into everywhere you see m. Well, there's actually only one spot. So we'd have 3, then 6 minus 2, which is 4, plus 5, equals 12 take away negative 5. We already did that, right? Right here, 12 plus positive 5, it's 17. Is this true? Well, let's see. 3 times 4 is 12 plus 5, and 12 plus 5 definitely is 17. We got it right. So it works. No matter how hard the questions are, how complicated they are, you can always check your answer if you wish. All right, next question. We need to get rid of any brackets. We don't have any. Next thing we want to do, step number 2, is look for like terms on the same side of the equal sign. They must be on the same side. So let's just look on the left-hand side here. Is there anything we can combine here? No, absolutely not. So maybe I'll just rewrite that right now. 5x over, or divided by, negative 4. How about on the other side? Anything you can combine? Yes, negative 3 take away 2. So we can again add the opposite. We're going to make this plus, and the opposite of 2 is negative 2. 3 negatives and 2 more negatives make 5 negatives. So there you go. All right, now we want to get this x all by itself. So why don't we deal with the negative 4 first? We want to get rid of this negative 4, and we also want to get rid of the 5. You could do it in either order. I'm going to do the negative 4 first. So what's this negative 4 doing here? It's underneath this, so it's dividing by negative 4. So we'll do the opposite dividing. We will multiply. And we're going to multiply by exactly that, negative 4, so it'll cancel out. What we do to one side, we have to do to the other. So we're also going to multiply this by negative 4. So those cancel, and you're left with 5x on this side. On the other side, negative 5 times negative 4. 2 negatives make a positive, and 5 times 4 is 20. Last step, this is 5 times x, so we do the opposite and divide by 5, and you get x equals 4. Okay, let's pick up the pace a bit. Any distributive property here? No, none at all. So let's look at just the left side. Anything we can combine? Yeah, there's a couple things we could combine. We could do the 5w and the negative 8w, and we could also do the negative 6 and the plus 1. So let's do that right now. 5w take away 8w, so we have to do 5 take away 8. Well, if we add the opposite, you end up with more negatives, and there's 3 more. So that means we have negative 3w. Then you have negative 6 plus 1. You have more negatives, so it's going to be minus. How much more is 6 than 1? 5. So there's that side simplified. Now let's look at the other side. Is there anything you can simplify here? Absolutely. You have negative 4, take away negative 6. We can add the opposite. What do you have more, positives or negatives? Positives, because there's 6 of them. And how much more is 6 than 4? 2. So there you go. All right, and we take it away from there. Let's try to add first. So I'm going to add 5 to both sides. That leaves me with negative 3w equals 7. This is negative 3 times w, so I do the opposite. I divide. Make sure you divide by exactly the same thing so you can cancel it. And do the same here. Divide by negative 3. Negative 3's cancel. You're left with w equals positive divided by negative is a negative, and 7 divided by 3 you can't do. It doesn't go in evenly. So this is totally okay to write it like that, or you could write it as a mixed fraction. How many 3's go into 7? 2 with 1 left over, and 3 remains your denominator. Make sure it's still negative. Or you could put it in your calculator, and you'll get negative 2.33333333, so 3 repeating. Any of these answers are fine. Next one, any distributive property here? Yes, right here is some distributive property. So let's do that first. I know you could simplify this part right now, but I'll just go like this. Negative 3 times 2z. Well, negative 3 times 2 is negative 6, and there's still the z. And then negative 3 times positive 1 is negative 3, and we still have minus 5z, minus 4, and plus z. Okay, let's look just at the left-hand side. So we have 4 take away 6. Well, 4 take away 6 is negative 2. If you don't like that, you could also do 4 plus negative 6. Add the opposite, you get negative 2. Equals. On the other side, I think we have a whole bunch of stuff we can combine, don't we? We've got a bunch of z's. We got negative 6z, take away another 5z, plus 1z here, isn't there? So negative 6 take away 5. That's the same as negative 6 plus negative 5. 2 negatives, it stays negative when you add, and you add them together, the 6 and 5, so you get negative 11z plus 1z. So what do you have more of, positives or negatives? Negatives, so we know the answer is going to be negative. And how much more is 11 than 1? 10. So you get negative 10z. Okay, now we also have negative 3 take away 4. So negative 3 take away 4 is the same as negative 3 plus negative 4. Two negatives, so it's still going to be negative, and we add the 3 and 4, and you get 7. Great. Now we want to get this z by itself. Look for adding and subtracting step first. I'm going to add 7 to both sides. Negative 2 plus 7. I have more positives than negatives, so it's going to be positive, and 7 is 5 more than 2. And on this side, I still have the negative 10z. This is negative 10 times z, so I do the opposite. I divide. Make sure you divide by exactly the same thing so it cancels. And on this side it cancels, you just get z. On this side, you have a positive divided by negative, which is negative. 5 divided by 10 does not equal 2, people. 10 divided by 5 is 2. This is 5 divided by 10, which you can't do evenly, so you can write it like that. That's not an acceptable answer, is it? Because you need to put it in lowest terms. So if you divide them both by 5, you get negative 1/2. So your possible answers, I don't know, I'll just write it again over here. Your possible answers are negative 1/2, or if you want, negative 0.5, if you want to turn it into a decimal. Those are the correct answers. Alright, these are getting pretty crazy now. Do we have distributive property? We sure do. We have distributive property in two spots. We have here where we have to multiply, and we also have here where we need to multiply. So we'll start with that. 4 times 2f, well 4 times 2 is 8, and it's still an f. 4 times negative 3 is negative 12. Then we have positive 2 times f, which is positive 2f. And positive 2 times positive 7 is positive 14. Then we have a minus 5 and a negative 20 plus 17. Okay, time to combine like terms on the same side. So let's cover this up and see what like terms we have. Let's look for our f's first of all. I see 8f's here, 2f's there, and that's it. 8f plus 2f is 10f. Then for our constants, we have negative 12 plus 14, and then take away another 5. So negative 12 plus 14, well, you have more positives, and how many more do you have? 2. So now we have 2 take away 5. You probably know what that is. If you want, you can add the opposite. So you have more negatives, and how many more do you have? 3. So 10f minus 3. On the other side, we have negative 20 plus 17. Do you have more positives or more negatives? You have more negatives. How many more do you have? 3. So there's your answer there. Okay, we want to get the f by itself. Let's look for an adding or subtracting step. Well, I see this minus 3, so I'm going to add 3 to both sides. I know you're getting nervous, but don't worry. You still have 10f, and the 3's cancel. On this side, do you have more negatives or positives? You have the same amount, so it equals 0. It's okay. Don't panic. This is 10 times f. You do the opposite and divide both sides by 10. So you end up with f equals, what do you got over here? 0 divided by 10 is 0. Okay, next one, any distributive property. Yes, two spots again. We're going to be very careful here. You see why in a second. Okay, so we'll leave the negative 2 minus 3 for now. I know you could combine that, but what the heck. Negative 4 times 2, well, it's only one negative, so it's negative 8. Negative 4 times negative 3z. It's going to be positive because there's two negatives, and 4 times 3 is 12z. Now be careful. Don't put a minus sign here. You're going to multiply negative 2 times 4z and negative 2 times positive 3. People often get the last sign wrong here. They usually get the negative 2 times 4z right and get negative 8z. And then they go 2 times 3 is 6 and put plus 6. That's wrong. It's negative 2 times 3, which is negative 6. Okay, if we look on the left-hand side, we have negative 2 minus 3. If you want to change that into an adding question, it would be plus negative 3. Well, negative 2 plus negative 3, that's two negatives, so it's going to be negative, and 2 plus 3 is 5. Equals. On the other side, let's do our z's first, why not? So we have a positive 12z and a negative 8z. 12 take away 8 is 4z. So 4z, and then we have negative 8 take away another 6. So if you want to write that as an adding question, it'd be negative 8 plus negative 6, because you're adding the opposite, right? So all negative, so it's going to be negative, and 8 and 6 together make 14. Get the z by itself, you have to add 14, do the opposite of the negative, so add 14. Negative 5 plus 14, you have more positives. How much more is 14 than 5? 9. Equals, this is gone, so you just have 4z. Last step, you have to divide both sides by 4, and you end up with z, I'm going to write it this way, z equals 9 divided by 4. Doesn't go in evenly. So you can write it like that. You can make it mixed. 4 goes into 9 2 times with 1 left over, so 1/4. Or you can put it in your old calculator and you'll get 2.25. Any of those are great. Weird questions, these last two, so watch carefully. There are some brackets here to expand, use the distributive property. 3 times n is 3n, and 3 times -2 is -6. Then we still have a minus 3n, and it equals -6. So if we look at this side, we do have like terms. We have 3n and -3n. So 3n take away 3n. Well, that equals 0n. Should I write 0n? No, if you have 0n, you have nothing there, so don't write it. The only thing you have left here is -6 equals. On the other side, do we have any like terms? No, all we have on that side is -6. So we have -6 equals -6. What the? Where'd the variable go? The variable canceled out, didn't it? The 3n and the 3n canceled out. We're left with this statement, -6 equals -6. Now, is this a true statement that -6 equals -6? Yeah, it is true. And whenever this happens, where the variable disappears and you're left with a true statement, like -6 equals -6, or 5 equals 5, or 1/2 equals 1/2, what that means is any number that you put into the n here will work. So in other words, all real numbers, we say, work. If you want the fast way to say real numbers, you put 2 lines down and make a big R. People call it the Rolls-Royce symbol in my class sometimes. That means all real numbers. So you could put any number you wanted into this n and this n. We have 2 n's here. And if you put any number you want into this n and this n, it will work. Let's try, I don't know, 2. If you put 2 in here, 2 minus 2 is 0, and 3 times 0 is 0. And 3 times 2 is 6, so you have 0 take away 6, which is -6. It worked. Okay, let's try a different number. Let's try 10. 10 minus 2 is 8, and 3 times 8 is 24. 3 times 10 is 30, so then we'd have 24 minus 30, which is -6. It doesn't matter what you put in there, it's always going to work. Pretty cool, right? How about this one over here? Okay, again, you have some distributive property, 2 cases of it here. So I have -42 take away 10 equals 4 times 2n is 8n, 4 times -1 is -4, -8 times n is -8n, and -8 times 1 is -8. Okay, let's look at the left-hand side. -42 take away 10. That's the same as -42 plus -10. So you're going to add those two together, get 52, and it's going to be negative. -52 equals. On the other side, you have some like terms as well. You have 8 take 8. Well, wait a minute. That's our 0 again, so we're not going to write anything down. And then you have -4 take away 8. -4 take away 8. Same as -4 plus -8. So that is -12. Okay, so again, the variable dropped out, but this time you don't get a true statement. Remember, -6 equals -6. This is true. But -52 equals -12. This is not true. So what does that mean? That means all real numbers don't work. In fact, no real numbers work. There is no number that you could think of that you could put into this n and this n, and it would make the left-hand side equal the right-hand side. It's impossible. Don't waste time trying to find it, because it just ain't happening. Alright everyone, these are getting pretty complicated, aren't they? Still got 2-3 more steps to go.